Hey guys, these are your notes on Strobe Photos. We're going to look at this picture of a basketball to start out. We'll take the cars kind of off the screen there a little bit. And I want you to listen to the picture of how, the explanation of how this picture is made. So it looks like there's maybe 50 basketballs on the screen. But that's not what happens. The way it's made is you simply bounce a basketball in a dark room, and you capture the image of it bouncing with a camera. But instead of that camera opening its lens for just a moment to capture a flash of light, the lens stays open for a good couple seconds. Usually what that would produce is one big blur of orange. If you kept the lens open for a couple seconds, it's called a long exposure. But it's done in a dark room. If it's done in a dark room, you wouldn't see the basketball at all. But what they use is a strobe light that flashes maybe every 1/10 of a second. So you actually see the basketball, a picture of it, only when the strobe light flashes. Because that's the only source of light in this dark room when the photo is created. So that's how a strobe photo is made. And what does a strobe photo shows us? Well, a strobe photo shows speed and acceleration. All right. First, let's look at how it shows speed. Where is the basketball moving the fastest, and where is it moving the slowest? Well, just think about what gravity does to the basketball while it bounces. Gravity tends to pull the basketball down. So as it goes down, we usually know that when things go down, they speed up. Gravity kind of makes things speed up before they hit the ground. And you could see what that does to the spacing of the pictures is it makes the spacing a little bigger when the basketball speeds up. So we could kind of circle some spots here, and we could say, in your picture, I want you to do this. You don't have to make a really complicated, big picture like this, but give yourself 2 bounces, more spacing at the bottom than at the top. All right, that's what I want to see in your notes. So look at the spacing here, for example. More spacing means that the basketball is moving faster because it covers more distance while in between strobe flashes. And you can see when the basketball rises, so it's faster right there. Do that on your own picture and circle that and say faster, more spacing. Okay. I want you to do this as well. Circle the top where the basketball seems to be just crawling over the top of that hill right there. And you know when the basketball rises up, it kind of slows down before it drops back down. So here, where the basketballs are close, it doesn't cover a lot of distance between strobe flashes. So this means slower, less spacing. That's how you can tell faster and slower from a strobe photo. You just look at the spacing. If there's more spacing, it's faster. If there's less spacing, it's slower. Alright, so get those 2 indications, faster and slower, in your notebook with the picture of the basketballs. Alright, so you could also kind of make a type of strobe photo with just oil drops from a car. Right, so I'm going to obscure the title here. I'm going to say cars making oil drops. These are really our big reference for our notes right here. We're going to have 5 examples. So you could draw a car at the right side for 5 different rows. And our first example is going to be slow. You could draw that at the left side of your row. But it's also going to represent slow, constant speed. Alright? And you could kind of make all the titles of each row kind of blocked off right there. Our second example is going to be medium, constant speed. So it's going to be going a little faster in our second example, but still at a constant speed. Our third example is going to be fast constant speed. So let's just look at these three for now. We want to draw, say a car, is accidentally leaking some oil and it's dropping it on the ground as it's moving. What do those oil drops look like? This is basically a strobe photo. What do they look like when the car moves slowly, but at a constant speed, at a medium constant speed, and at a fast constant speed? Well, the oil drops look quite close together when the car is moving slowly. But can you notice one other thing about these dots that I'm showing? Slow constant speed means close together, but they're also equally spaced because the car goes the same speed every time it drops a new drop of oil. So every dot has the same amount of spacing between it. That means constant speed. How would medium constant speed be different? Well, the difference is going to be just a little more spacing between the dots. But you should still draw the dots equally spaced out because that shows that it's going at a constant speed. How would a fast constant speed be different? Well, it's going to be different with more spacing between the dots, showing that the car is going really fast. It covers a lot of distance between each drop of oil. Right, so that would represent a fast constant speed. But they're still equally spaced because the car covers the same amount of distance between each drop. So why don't you write below the 5 rows you drew that equal spacing in a strobe photo, what does it mean? It means constant speed. Alright? So our last two examples will not be constant speed. They're going to be speeding up and slowing down. Speeding up or slowing down means you're accelerating when your speed changes. So we're going to call speeding up. We're going to start with that. That's also known as a positive acceleration. Positive acceleration. What would the dots look like if the car speeds up? Well, that means it goes from slow to fast. So if I start with slow here at the left side, here's where the car started on the left side of the page, and there's where it ended up. So where it starts, I'm going to show the dots really close together to show that it started out really slow. And then progressively, the spacing will just get a little larger each time. And that shows that the speed is getting greater. So they're speeding up. And our last one, slowing down, also known as a negative acceleration. So slowing down means you hit your brakes. So you started out going fast, covered a lot of distance between drops. Let's check. There we go. A lot of distance between drops. And then it eventually went to very little distance between drops as you slowed down to a rest. So that would show slowing down when you go from really fast, a lot of spacing, to really slow and almost stopped with no spacing at all.